Let's remember that negatives are no different than the concept of opposite, and we explored this when we were doing our visual arithmetic. So when we're talking about negatives, negatives just simply mean opposite. So this right here is the opposite of 5/7. That's a little odd, so let's sketch it out. We're going to start off with something that we divide into sevenths. 1, 2, 3, 4, 5, 6. Oh, I need one more. I might tack it on right here. 7. So I need sevenths. And then I need 5 of them, but this needs to be the opposite of 5 of them. Weird to represent, so let's maybe just color it a different color. We'll call red the opposite of something. So this would be the opposite of 3, 4, 5/7. Remember that in our visual arithmetic lesson, we talked about the idea of blocks and anti-blocks, or the idea of pile and holes. Well, you can just think of these as being holes that are this size. So we're going to shade them in red to keep them different. Now this is going to be combined with 4/9. 4/9 is where I need to divide this into 9 pieces, so we're going to go through this and make it into 9 pieces. 3, 4, 5, 6, 7, 8. I think that's 9 just about. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we have it. And we need 4 of those, so I'm going to claim those in with blue. So we've got blue, which is going to represent our objects, and then we're going to have red, which is our anti-objects. Now we can still create a common denominator where we're going to divide these in the same way as each other. So we're going to divide this 3, 4, 5, 6, 7 pieces going one way, and in the other way we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now they're the same size, and the advantage of this is that we can take these blocks and anti-blocks and we can use them to cancel each other. We can use them to annihilate. So this one is going to cancel with, let's say, this one, and down the row these are going to cancel, and there's going to be a bunch that happens there. Now that's enough for us to get the idea. Let's go back to the numbers so that we can see how this actually works. We are starting with the 5/7, the opposite of 5/7, and we are adding 4/9. So the first thing we need to do to relate any of these is again get a common denominator. So that's going to be, well, if I make 9 times as many cuts in the first brownie tray, that's going to be 5 times 9, where I get 9 times as many pieces, but each of them is 1/9 the size. So that's going to be the opposite of 9 times as many pieces and 9 of the size. And then we're going to add that to 4, where 4 was split into 7 pieces, and on the denominator we have 9 that was grown into 7 pieces as well. So that means that what we now are considering is -45 of these 60/3, where we are adding that to 28 of these 60/3. So let's now think to ourselves, if I have 28 objects and 45 opposite objects, anti-objects, some of those are going to cancel away. Well, we can look at that through a couple of different ways. We can look at it as a little side problem of saying, what is -45, 45 opposite objects, plus 28? That's going to create, well, more opposite objects than I have regular objects, and in fact I think it's going to come out to 17. I think there's going to be 17 opposite objects that are left over. If that feels a little weird, you could also do 28 minus 45, which would still get us -17. That's where we start with the 28 real objects, and we peel away, we cancel away one at a time, and we look at how there's going to be 17 objects, or anti-objects, that are still left over. Well, now we can go back up to our fraction. We can do a little bit of thought for here. We could either have looked at that as -45 plus 28, where the size is still 60/3, or we could have looked at it where we had 28 and we were taking 45 away, or attempting to take 45 away, where there's still size 60/3, and in either case you're going to get 17 anti-objects that are left over, each of which is a size of 60/3. So this becomes the similar thing to what we were working with when we did our arithmetic. If we keep in mind that fractions are nothing more than a story for the size of the brownie cuts that we have, then when we are adding negatives or subtracting negatives, we still need to make them the same size, and then we just simply do the addition or subtraction we normally would have and we account for the size on the denominator. If we do multiplication, it's the exact same thing, but now we're going to look at it again through its story. So we're going to look at this as being the opposite. Remember that this means opposite. So the opposite of 5/7 of 4/9. Well, we know how to do 5/7 of 4/9. So the opposite of 5/7 of 4/9 is just going to be where I have 5 times 4 quantity of pieces and 7 times 9 quantity of pieces. And so it's going to be the opposite of whatever that is. The opposite of 20/63. That would be negative 20/63. So we've done two different problems and shown that they're the same as we would have done by just considering our positive fraction methods and the stories and models that we have from our visual arithmetic.